Hello again. So in our presentational video, we introduced a few new formulas and threw a bunch of summations at you, and it might seem a little intimidating, but it's not that bad. So hopefully problems like this will help build your confidence in recognizing what the summation is in terms of whether it's like an average or a variance. So let's read the example. We see that there are 4 policyholders and for 7 years that we have data on. So R equals 4 and N equals 7, and what we want to find is the credibility factor. And here's our credibility factor Z, where it equals N over N plus K, and K equals EPV over VHM. So if this is too intimidating, we don't really know what this is, let's just go on to trying to find the credibility factor, which we know is Z, and then which has a K in it, and we know what K equals this. So then let's go ahead and write out what EPV is. Okay, so EPV comes out up here. EPV, remember, is just the average of the variances, and our variances is R. Our variances are simply just each risk minus the average of that risk squared divided by the number of periods for each of those risks minus 1. If we put this, if we bring that back over here inside there, we notice that this is what our summation comes out to in total, and what they gave us in the problem right here turns out to be this summation and this summation. So all we're really missing from right here is this and this. So if we plug in 4 for R and 7 for N, and we use these yellow right here as 50.4, which they gave us, we see 50.4, and then the values that we know right here, we get 2.1 as the EPV. Here we go, the EPV equals 2.1. And the variance of hypothetical means, remember, this is just the difference of the variance of the average risks minus the variability, the expected variability per period. And we can expand this out, and this is just, again, it's just a variance, the risks, and we notice that we are given this value right here, and all we're missing is this value right here, and also this value too, so additional value out here. So we take the green that we already know and we bring it up with the blue, which was given to us, and if we perform this calculation, the R we know, and then the EPV we just calculated, and the N that we also know, after we plug in those numbers, we will get 1.2 for the variance of hypothetical means. I should list it up here. EPV right here, and variance of hypothetical means right here. So now we can use these values. We can plug them in for our K. So that means K equals 2.1 over 1.2, which then we directly plug in here. And so Z equals N, which equals 7 over N plus this value for K. And if after we plug in those values, we'll see that Z equals 0.8. And so it makes sense that this is a fraction, or it is a value between 0 and 1, because Z, it's a credibility factor, but it's also thought of as a weight, because what we want to get to is calculating the hypothetical mean, and the hypothetical mean, again, it puts some of the weight on the average of each risk. Do I have one written around here? No. These guys, it puts some weight on these guys, just the average of the risk, the average of the risks, and then it puts some weight on the overall average of all the risks. So this credibility factor, it gives some credibility to the average of each risk, and some credibility for all the risks in general, for the value of the average of all the risks. And that'll give us our hypothetical mean, which will help us understand more about our risk to the company or whomever that the risk is interesting to.